continue from where we stopped yesterday. We're dealing with the definite integral. So we got different types of integration problems, but now we have values to substitute. So why are we doing this? We're working towards the next topic, which will be calculating area and volume. Okay, which is it's a few marks, like around 10 marks here in 5, but very important for the next level. So I'm just choosing a few examples at random, but I'm trying to make it different. Right, so let's take the first one. So what do we have here? We got the integral from -1 to 1, y all divided by the square root of 25 minus y squared dy. Now, the main thing here is the integration. The substitution is easy, which you're going to do on the calculator. Right, so here, this is a fraction, but the numerator is not an exact derivative of the denominator. How do you know that? The denominator is the square root of 25 minus y squared. Do not only read what's inside there, you read the entire denominator. So if I have to differentiate the square root of 25 minus y squared, I have to use the chain rule, which is going to be half, and then 25 minus y squared to the power. You can see there's nothing there on the top that resembles a derivative. So therefore, this does not satisfy the division type problem. So this has to be multiplication. Let's rearrange it. So if I take this denominator to the top, the sign of the exponent will change, so that will become 25 minus y squared. Originally, it's a positive half in the denominator, and when you take it to the top, it will be minus half. Right, so now it satisfies this condition where it's multiplication, where you have f of x all raised to the power n. Here's it, your f of, well, in this case it's f of y, all raised to the power n multiplied by the exact derivative f prime x. You can use a substitution, or you can do it by inspection. So that's k f of x all raised to the power n plus 1 all over n plus 1 plus c. Now this deals with multiplication, where this is an exact derivative. Your power, there's a restriction here, your power must not equal to minus 1. So if your power is not -1, then it is okay to use this formula. So it's not -1 here. You can see that it's just -half. So I'm going to do it by inspection again. So this is like revision of integration. Again, each example we're taking now. So yeah, if I want to do this by inspection, alright, so let's see how I'm going to do this here. I've got my 1 minus 1, 25 minus y squared to the power -half. There's my y there, I'm copying it down. So I know this is what it is originally. Right, so the coefficient of y here is just 1 there. Alright, now the exact derivative of 25 minus y squared. Obviously the derivative of 25 is 0. The derivative of minus y squared will be minus 2y. Now it's an exact derivative, f prime, we can say that. So the problem was there was no -2 there. So all you do is you cancel that -2 by multiplying by 1 over -2. Why? Because -2 divided by -2 will get you back to what it was originally. We're not changing the question in any way. That is a positive 1. So what you just did now is you created the perfect situation. K multiplied by f of x to the power n. Well, in this case, f of y to the power n times f prime y. So once that is sorted, then the answer will be -1 over 2 f of x to the power n plus 1 minus half plus 1. So let me just write that down. Minus half plus 1 all divided by minus half plus 1. And then you got your plus c. This does not change on the inside. It will remain as 25 minus y squared. Now that is our normal integration, but remember here we do not have to put down plus c because we are going to be substituting these values here. So that's my 1, negative 1. Let me simplify this. So that's my minus half on the top, 25 minus y squared. Then I got minus half plus 1. Basically 1 minus half is just half. 1 minus half here is just half again. I got my 1, negative 1. So now, let me simplify further, although you don't have to go and simplify in the exam further because we are substituting values, but the fact is that half on the top, half in the bottom will cancel there. You can see that. So now, what remains is just negative, and then we have the square root of 25 minus y squared. That's all. And then you got your 1 minus 1. Alright, so now, how do you know if this answer is correct? You can always differentiate it. I'm just refreshing your memory. If you take this, if I say let maybe, what we call this here, let p equal to minus the square root of 25 minus y squared. And if I want to differentiate this here, so that's minus 25 and that's y squared to the power half there. So if I want to check my solution, I will differentiate it. So let's differentiate this here. So I just called it p, you can call it anything you want to, so that will be dp dy. I'm differentiating with respect to y here. So that's going to be minus 1 times half, which is minus half. Then I have 25 minus y squared, and then I'm going half minus 1. It's a chain rule. Okay, this is the chain rule. Half minus 1 is minus half times the derivative of 25, 0. The derivative of minus y squared is minus 2y. Alright, so now what's going on here? We got minus half multiplied by minus 2y multiplied by 25 minus y squared to the power minus half. It's all multiplication here. You can see that? So now, negative and negative, positive 2 and 2 cancel, you end up with y. Here you have a negative power. If I take this to the bottom, then the sign of the exponent changes. Sorry, this is a y squared there, 25 minus y squared to the power half, which is y all divided by the square root of 25 minus y squared. And let's check. Yes, it's perfect. You can say that. You know your differentiation, you cannot fail here. You must know how to check your solution. Okay, don't just work it out and hope for the best. You check if it's correct. Right, so this is just a way of checking. It can be done with all the exact derivative types. So this type here is the multiplication, then there's division also. Alright, so now we're not done. That was just integration. Now you know what to do. Take out your calculator, but first let's write this down. What we're going to do is substitute the upper limit here. That's going to be minus the square root of 25 minus 1 all squared there. You substitute your upper limit, put down a negative sign, substitute the lower limit there. So that will be 25 minus that squared again. Right, so we got a 1 there and minus 1. Okay. So now what do we get? So basically a 1 squared is 1, 25 minus 1 is 24, so you get minus the square root of 24 there. And then negative times negative is a positive, and it's the same thing, 25 minus 1. Remember, this is minus 1 squared, which is 1. Negative times positive is a negative. So this is plus the square root of 24, which is 0. Right. Now, we are getting a 0. Now, because we are working it out algebraically, when we deal with area, when we deal with area, we will not get 0. Okay, then we need to understand the graph. Right, because what we're actually doing here is we are working out the area bounded by the curve. Okay, bounded by this curve over here. If we integrate it, what did we have? Yeah, so it's an area from 1 to -1. Right, so, but anyway, this is fine. As it is, definite integral, use your calculator, 0 is fine, it's correct. Alright, so that was the first one. We're going to deal with the next one now. Alright, so our next example, we got sine to the power 3 times cos. Now, there's different ways to work this one out. Right, so you might be thinking of splitting your power, right, which you can. Right, so let's do it that way first, okay. Right, so, but it is not the fastest way to deal with it. I'm going to show you in a few seconds, but you can. If you want to follow the rules of powers of sine and cos, then the rule of odd powers is split the odd power. So if I split the odd power there, I've got my pi over 2, 0, that's going to be sine theta times sine squared. Right, so if I split my odd power, that's going to be sine times sine squared. Then, what do I do to sine squared? I use my square identity. So sine squared is 1 minus cos squared. Now what do I do? Now I will multiply cos within or inside the bracket. Why? Because I want all my like terms. Cos and cos. All the cos's within brackets. And the exact derivative of cos is minus sine. I want it outside the bracket. Right, so now if I multiply cos times 1, that's going to be cos. And then cos times cos squared, that's going to be cos to the power 3 d theta. Okay, so now what do we do? You notice now there's an exact derivative here. The derivative of cos is going to be minus sine. We can use inspection or substitution. Let me do substitution for this example here. So if I let u equal to cos theta, then du over d theta, the derivative of cos is going to be negative sine. Now I can make d theta the subject of the formula, which is going to equal to du divided by minus sine. Right, so now this is going to equal to the integral. You got your pi 0, then I have sine theta there, then I got cos theta. So there's cos theta, I'm substituting into this. Cos theta is now u, so that becomes u minus cos theta to the power 3, so that's going to be u to the power 3, and d theta is equal to du divided by minus sine theta. So what happens here is sine theta and sine theta will cancel. So I end up with minus the integral there between from 0 to pi, u to the power 1, u to the power 3 du, and now I can integrate. So that's my minus. I can integrate u to the power 1 and u to the power 3. So when I integrate u to the power 1, that will be 2 over 2. Integrate u to the power 3, that's 4 over 4, substituting pi and 0. This negative 1, I can multiply it inside, but I'm just going to show you now that you do not have to multiply the negative inside now, or any number. If you want to, you can work out your answer, and then your final answer multiply it by minus 1. It comes to the same thing. Now, So, okay, I'm not supposed to put the pi and 0 here because this is still u. It's not in terms of x. So let me substitute back. So what was u? And so my u was cos theta, cos theta. Now I'm back in terms of theta because a problem was given to me in terms of theta. So I'm substituting directly into theta, so it's 0 and pi over 2. Now your calculator. So you convert to radians. So your calculator in radians. Right, whenever you're dealing with trigonometry, it's best to work with radians, not in degrees. Right, especially when you're substituting values. You can see this angle is not in degrees. You cannot see the degree symbol here. So as it is, it's in radians. So you're going to go shift, mode. What number is it on the calculator? Let's see. Number 4, RAD there. So your calculator in radians, and then you're going to substitute. Right, so let me do the substitution. So first we're going to substitute pi over 2. Alright, so that's my pi over 2. First, the upper limit, wherever you see theta, substitute your pi over 2, put down a minus sign, and now substitute 0. Right, so calculator in radians, remember that. So what we will do is we'll work out our answer, and then we'll multiply our final answer by -1. Let's see what we get. Right, so here, look, from my trig graphs, I know if you know your trig graph, then you can work this out without a calculator. Okay, so we know that pi over 2, 180 divided by 2 is 90. I know that from my trig graph, cos of 90 is 0, so that's a 0, that's a 0. I know, first thing, 0. You got that? You get a 0 there? Yeah. I know from my trig graph that cos of 0 is 1. So 1 squared is 1. So that becomes 1 times half, which is just half there. Cos of 0 is 1, 1 to the power of 4 is 1, times minus 1 over 4 is minus 1 over 4. Right, so basically I got minus 2 over 4, minus 1 over 4 there. So 2 minus 1 is 1, that's 1 over 4, so that becomes minus 1 over 4. So when you do your calculator work, the result of everything except this -1 should be a minus 1 over 4. Then your final answer times the -1 will be positive 1 over 4. You got that? Check. Well, I'm working it out without a calculator. Alright, so but you must get used to using the calculator. Check how you are typing out. You do it now, make a mistake, and then you correct it. If your brackets are wrong, your answer will be wrong. So when you are typing this out on the calculator, you know that obviously you need to open up a bracket here, close the bracket, and then you put your power. Okay, so let's see how I got my brackets here, if all my brackets are 100%. So here I'm opening Right, so because I need to deal with this here, open, close there, close there. So you rather work out this part individually, clear your calculator, then work out that. It'll be too complicated to type out the whole thing. Okay. You must figure out a way that works for you. Or you should have figured it out. You've been in school for 12 years. You know what works for you, what doesn't work for you. Okay. So that is this example. Just double check on the calculator. Does everyone get the same final answer? Right. So now, this took quite long to do. You can see that. Now the previous example, the one that we just did a few minutes ago. Right, it was given to you as division, we wrote it as multiplication, exact derivative. So this is an exact derivative example. Right, I just wanted to show you the difference. So now let's take the same example. Let's take the same example, number 8. Now, don't rush and follow the rules of powers of sine and cos. First thing you always do, no matter what, you are always checking for exact derivatives for every single example that comes out. Right. So you will notice now that what is the derivative of sine? It's cos. So what are we dealing with here? We are dealing with the same thing. It's f of x to the power n multiplied by f prime x dx, which is equal to k f of x to the power n plus 1 over n plus 1 plus c. This satisfies that condition there. So this is all unnecessary work. Okay, it's unnecessary work, you can see that, but it's still correct. It's correct but unnecessary. Why am I saying that? Let me show you. What is the derivative? Here's your f of x now, or f of theta. You can see that. What is the derivative of f of x? F prime x. What is the derivative of sine theta? Cos theta. So therefore, the answer is going to just be sine theta to the power 4 over 4, and you're done. There's my pi over 2. There's 0 in one line. You got your answer. Look at the difference here. Right, so now, that's why you must know your differentiation. So now the derivative of sine is cos. Again, let me just repeat. F of x, f prime x, f of theta, f prime theta. It satisfies the condition. One time, you get your solution. Now let's substitute. So this is going to be 1 over 4 sine of pi over 2 to the power 4. I'm substituting my upper limit minus substitute my lower limit, which is 1 over 4 sine of 0 to the power 4. And now you can work this out. Pi over 2, that means sine of 90. I know my trig graphs. Sine of 90 is 1. 1 to the power 4 is 1. 1 times 1 over 4 is 1 over 4. You can check that out on the calculator. This is 1 over 4 minus sine of 0 is 0. 0 to the power 4 is 0. 0 times 1 over 4. So basically it's just a 0. And now what is 1 over 4 minus 0? It's 1 over 4. Simple. You can see that? That's why you must know your differentiation. Look at the difference in these two examples. It's the same example, done in two different ways. Alright, so our next example, number 22 from exercise 5.1. So now, when we look at this, it is a fraction. Right, it's a fraction. Now we are integrating with respect to t. That doesn't really matter. Whether if it was a dx, then this will be 4 plus x squared. If it was dy, then it will be 4 plus y squared. So that is just a variable. The main point here is that it is a fraction. Let's check this denominator. The denominator is t squared, or 4 plus t squared. If you differentiate the t squared, it's going to be 2t. Do you see a t here? No. That means the methods that I've been using in the previous example, exact derivative, does not apply here. You can see that. So if your exact derivative method does not apply, then this could be one of two things. It's either integration by parts or it's trigonometric substitution. Right, so you can see this does not look like integration by parts. So now this, you must be familiar with your standard forms for trig substitution. So watch how I'm going to rewrite this here. So you know on the top, if there's no variable, there's no number written, it has to be a positive one. Then the 4 can be written as 2 squared, and then you got your t squared there. And there's your dt. Now you need to think, what did you differentiate? Because these ones on the latest formula, the formula sheet does not have these directly under integration, but you look for it under differentiation. So let me just refresh your memory. So if you could have inverse sine of x, or inverse cos, inverse tan, those are the three main ones, and then you have there's other three. So sine, cos, tan, inverse sec, inverse cot. Now, but if this is y and the exact derivative y prime, so when you see the -1, it does not mean exponent -1, it means arc sine or, you know, inverse, basically. On shift, when you press shift sign on the calculator, that's what you see there. So the derivative here is going to be 1 all divided by the square root of 1 minus x squared. How did I get this 1? It's actually, this is f of x. F prime x, the derivative of x is 1 all over the square root of 1 minus x squared. Then your derivative of inverse cos will be -1 all over the square root of 1 minus x squared. And inverse tan will be 1 all over 1 plus x squared. Right, so this is under differentiation. So now if you look at what we have there, let's say if I had inverse tan of t, if I'm differentiating with respect to t, then the derivative of t will be 1 all divided by 1 plus t squared. Okay, so let's write this down properly. The proper formula is, if you have inverse tan, let's call it f of x. This is how you must know it. So for any case, you can work it out. Then the derivative of inverse tan f of x is going to be f prime x all divided by 1 plus f of x all squared. Right, so that is, so when you look at that, you must realize that this is a derivative of inverse tan. But now, the actual formula to do this, let me write it down, which is supposed to be on the formula sheet. So this is 1 over a squared plus x squared. Right, so this is how it's given to you in N5. In N6 you have the B here also. But the fact is, if you got 1 over a squared plus x squared, then this can be written as 1 over a inverse tan x over a plus c. Okay, so this is working backwards. So basically what am I doing? I'm going from here back to there. That is integration. 1 over 1 plus t squared. When you integrate it, it becomes inverse tan t. So if I want to do this, then my a represents a number. So that is not the variable. So here's my a squared, that is 2 squared. Well, then it's x here, but you know it's t there. So the formula is 1 over a, 1 over 2, inverse tan, x over a, well, you know it's not x, it is t over 2. Oh, I forgot to write down our limits to integrate here. What are we dealing with? 1 and 0. That was a 1, 0, 1, 0 there. That's a 1, 0. Alright, so now let's work it out. So the main part here is the integration part. Now we need to substitute. Let's substitute our values. So that's 1 over 2 inverse tan. You're going to substitute your value there. Minus 1 over 2 times inverse tan. You will substitute your value there. You need to get familiar with typing all this out on the calculator. First we are substituting 1 and then 0. Now, best to convert your calculator to radians. We are dealing with trigonometry. Right. So we will give our answer in radians, not in degrees. Give me the calculator. So, okay, the calculator is in radians. So let me go shift 10. Inverse 10 on the calculator, shift 10. 1 over 2. So here you get 0,2318, 238 and a few other digits. Inverse 10 of 0, well you know that's 0. Right, so your final answer rounded up to 3 decimal places, 0,232. Check the final answer there. Correct. Let's see how the textbook final answer. This is exercise 5.1, number 22.
Zero point two three two.
0,232. So leave your calculator in radians all the time. Not all the time, I mean when you're dealing with these things in trigonometry, integration. So be careful, when you see a fraction, you need to check for exact derivatives. If there's no exact derivative, then it's either trig substitution, but here we're not doing the long actual trig substitution, we're just applying the relevant formula. You can see that. Right, so the next one. So now we have r all divided by the square root of r squared minus x squared. So remember here we are integrating with respect to x. That means r is a constant. Right, so it's like 2 here, maybe 2 squared minus x squared. So you treat r as a number. Okay. So now, if r is a number, then this number here, we know that it's not a derivative, obviously, of x squared. So let's write down this and take the number multiplied by whatever's in front. So now we can have a clearer picture of this problem here. This is 1 all divided by the square root of r squared minus x squared dx. Now you check. Obviously, this does not involve exact derivatives because this is an x squared. There's no x here. So that means now this is trig substitution. We are applying the relevant formula. So which formula has the square root in the denominator? Which is the first one and the second one. Okay, both. Right, so now the second one has a negative on the top. Can you see that? The first one has a positive. We can see that this is a positive there. So now this is under differentiation. How do you use it? How do you actually use the formula? So let me write that down. So when you have the integral of 1 divided by the square root of a squared minus x squared. Right, so here, well, a squared is just 1 here. This is just an example. This is the formula. So this is just going to be inverse sine x over a plus c. There's no 1 over a here. Okay, so this is the one that does not have 1 over a. Yes, for inverse tan you'll have 1 over a and for others, but not for this one. So it's just straightforward inverse sine x over a. It's different from inverse tan. Right, so there's it here. Your a is r. You can see that. So now I can go straight to the solution. Okay, this r is just a constant. I'm leaving it outside. I want to integrate this. That will be inverse sine x. You can see x over the constant here. So that's going to be x over r. We don't have to put down plus c. We are ready to substitute our values. R, negative r. Right, so now let's do the substitution. So this r here, it's up to you if you want to leave it inside or outside. If you leave it outside, then you will work out everything and then your final answer multiplied by r. So let me do it that way. So there's my r there. So all I'm going to do is first substitution is going to be inverse sine. I'm replacing x with r, so that's going to be r over r. We're clear with that? Put down a minus sign, and now it's inverse sine minus r over r, because I'm replacing the lower limit with minus r there. So let's see what happens. We simplify this, obviously without a calculator. So this is going to be inverse sine r divided by r is just 1 there. And then we got minus inverse sine again, minus r divided by r there, that will be minus 1. Now you can use your calculator if you want to. Right, so, but these values of 1, and these are all special angle values. Okay, so if you know your trig graph, what do I mean? Let me just show it to you quickly here. But by that time you can now use your calculator and check and verify this here. Right, so basic sine graph. Let's say y is equal to sine of x. You know your basic sine graph, you know 0, 90, 180, 270, 360 degrees. So this is 0, 90, 180, 270, 360. This here will be, obviously it's going to be now minus 90, and this one will be minus 180, this will be minus 270, and this will be minus 360 degrees. Okay, so now, what does this mean, inverse sine of 1? It means that when the y value is equal to 1, what is the corresponding x? It's the other way around. Normally, we want to know if we work out an x value, what is the corresponding y value? Now, this is a y value. We want to know what is the corresponding x value. So, we know that the sine graph amplitude is 1, negative 1. I mean, you go up 1 unit, down 1 unit. So, when inverse sine of 1 means when y is equal to 1, you can see here, look at this point here. This is the point where y is equal to 1. Can you see that? At the turning point. So, what is the corresponding x value here? 90 degrees. Right. Or in radians, pi over 2 because we're working with radians now. Okay, you're going to put your calculator in radians. So it's either 90 in degrees or pi over 2. So that's what it means. Inverse sine of minus 1, it means where is y equal to minus 1? So there's minus 1 here. So if I draw a line here, there's the point minus 1. And there's also another point here, minus 1 also. Can you see that? But now we know for our, well, I didn't do the trig graph. I need to show you the trig graph, the inverse sine graph. Right, so we will work with the one that's very close here. From minus 90 to 90. So we know that y is equal to minus 1. What is the corresponding x value when y is equal to minus 1? Minus 90. Can you see that? So there's minus 90 degrees there, which is actually in radians, it's minus pi over 2. Right, so let's do it here. So inverse sine of 1, we know is 90 degrees. In radians, it's pi over 2. Minus, okay, minus inverse sine of minus 1. We know it's going to be minus pi over 2. Can you see that? So now, what's going to happen here? I got my r, then I have pi over 2. Negative times a negative, that will be a positive pi over 2. So you got half pi plus half pi. That's one full pi. Right. Half plus half is 1. Right, so now r times pi will equal to, or let's just write it as pi r. That's all. Nothing more we need to do then. Pi r, or your calculator will give you 3.142, am I right?
Yeah.
3.142 times, but if you leave it as pi, it's fine. Because we know pi is 3.142, but not exactly 3.142, that's just the first 3 decimal places. Alright, so number 5. So this is a fraction. Remember, there's many fractions here, but the way you integrate them, you need to check a difference. Okay, all depends now. If you have a fraction where the numerator is a derivative of the denominator, then you know you're taking ln of the denominator. So if you have a fraction where there is no exact derivative, then it could be trig substitution, like this, like example 22, example 3 here. Now this is a fraction, but you have x on the top here also, and there's in fact there's x squared on the top. Okay, but the fact is you're always checking, is the top a derivative of the bottom? Obviously it's not. So this involves algebraic substitution, or when you read this, it is a fraction. Basically, let me just rephrase. This is an improper fraction. It's an improper fraction because the numerator is of a higher power than the denominator. It's larger. So that's a 2. The highest power of x here is 2. The highest power of x here is 1. So this can be done by long division, but let me do it the long way first. Let's do it both ways so you can see that we must come to the same answer no matter what. All right. So now, you know our substitution here. Let u equal to x plus 3. Then du over dx, the derivative of x plus 3, that is just 1 plus 0, which is 1. Alright, so let's make dx the subject. So du is equal to 1 times dx. So basically dx is equal to du. Alright, now we have a substitution for the denominator in terms of u. We need the numerator also in terms of u. So we go back, u is equal to x plus 3. So let's write that down. U is equal to x plus 3. So now I need x squared in terms of u. So u minus 3 will equal to x. So now this is not x, it's x squared. So now there's an equation, square both sides. So now u minus 3 all squared is equal to x squared. It's either you want to do the substitution straight or you can square it, but you have to square it no matter what. So let's do it here. So this is equal to, you got your 2 and minus 2. Alright, just double check those values, 2 and minus 2, if it's correct in the question, right? So that's 2 and minus 2. And x squared now, that's u minus 3 all squared, all divided by x plus 3, which is u. So there's my u there, and dx is equal to du. Correct? Right, so now that's 2 minus 2. Now you square a binomial, you're squaring 2 terms, you know you're going to end up with 3 terms. Okay. So now the first term, that will be u squared. Middle term is going to be 2 times term 1 times term 2. So that's going to be minus 2 times u times minus 3 is minus 6u. And the last term will be minus 3 squared. Will always, first and last must always be positive. That's plus 9, all divided by u. You can write it as times u to the power minus 1. It's up to you, but I'm going to leave it as it is. Now you can see that this is not in standard form. I'm going to separate them into 3 fractions. How do I know 3 fractions? Because I got 1, 2, 3 terms in the numerator. So this is u squared over u minus 6u over u plus 9 over u du. Oh yeah, this is definitely a good example here to do. So now we simplify u squared divided by u. That's just u. U and u cancel, that's 1. 1 times minus 6 is minus 6. 9 divided by u is the same as 9 multiplied by 1 over u. You never ever take u to the top and make it a negative 1. Right, because your power must not be negative 1, because you cannot use the formula minus 1 plus 1. You're going to get 0. You're going to get 0 in the denominator. So if it's a negative 1, you will leave u in the bottom. Alright, so now there's nothing more to do here. That's du. Let's integrate with respect to u. So now you know that this is just u to the power 1. When you integrate it, that's going to be 1 plus 1, which is 2 over 2. Integrate 6, that will be 6u. When you integrate 1 over u, it's ln of u. So that's going to be ln absolute value of the denominator. And that is 2 minus 2. Now you've got 2 options. Option is you can change the limits if you want to. But I'm not going to go and change the limits now. Let me just substitute as it is. Sorry, so that means I must not put down my 2 and minus 2, because the 2 and minus 2. Alright, this 2 and negative 2, where is it here? The 2 and minus 2. This is the original problem. It's an x value and an x value. It's not a u value. Right, if you can make it a u value, you know what to do. But let me just go and substitute straight. So that's my 1 over 2 u squared minus 6u plus 9 ln u there. What was my u? U was x plus 3. Right, so now I got my 2 and minus 2. Right, so you know what's going to be happening here. Now I'm going to take my 2, substitute in place. I'm not going to go and write this whole thing down now. Right, I'm just going to use a calculator there. So let me just substitute my 2 there. So you check also. Now this does not involve trigonometry. So it doesn't matter whether it's in degrees or in radians. Your calculator, you're going to come to the same answer. So let me type this out. Right, so when I substitute 2, you can double check me here. I'm getting minus 3.015058788. Just double check. I'm working fast on the calculator. Double check me there. Correct. Right, so when you substitute minus 2, you get minus 11 over 2. Alright, you can always double check that. So that is minus 11 over 2. So now, let's work this out. So it's going to be this answer, minus times minus is a plus. So that's going to be plus 11 over 2. Check the answer there. Okay, so this final answer is 2,4,8,4,9,4,1,2,1,2, which is 2,485, rounded off to 3 decimal places. Is that correct? It's correct. Okay, correct. So you check that. Alright, so that was method number 1, using U substitution. Now, method number 2. Long division. Right, so long division. Let's check. So we got our x plus 3, and you have x squared plus 0x plus 0. Remember, don't forget to write all that down also. Right, so long division, the rules are divide, multiply, subtract, bring down the next term. Okay, so divide, what are we dividing? We're going x squared divided by x, the result is x. Multiply, x times x, which is x squared, x times 3, 3x. Subtract, top minus bottom. Top, you know, I showed you how to do that properly. You can do it horizontally, you can do it vertically. The main thing is to not make a mistake here. Alright, so x squared minus x squared, nothing, that's 0. Alright, top minus bottom, 0x minus 3x is minus 3x. Are you clear with that? Like 0 minus 3 is minus 3. Bring down, well, there's nothing to bring down. It's just there's nothing, it's 0. So we go 1, 2, 3, 4. We're done. We check again. Is it possible to divide? Yes, that's x and that's x. You can obviously divide that. You can see that. So minus 3x divided by x is minus 3. And minus 3 times x will be minus 3x. Minus 3 times 3 is minus 9. So that was divide for the second time, multiply for the second time, subtract now. Okay, so you're subtracting. So top minus bottom, minus 3x minus 3x becomes minus 3x plus 3x, which is 0. So that's nothing there, that's 0. Now top minus bottom, 0 minus 9, which will give you a positive 9. So this is your remainder. Right, so how do you represent all this information here? See, some of you all made a mistake in the test too. You're doing the long division, but you went and mixed up the stuff over there. Okay, you don't mix it up now. So this x minus 3. So this is equal to the integral of x minus 3. Here's your quotient here. Plus the remainder. The remainder is 9 all over the original denominator there, which is x plus 3 dx. So this is equal to this here. How do you know that? Test it out on a calculator. Substitute a value into the original. You will get you'll get an answer there. Substitute the same value into this answer here. It must be equal. If it's not, then it means we made a mistake somewhere. So now this is the long division process, and now we can just integrate x. That will be x squared over 2 minus integrate 3, that will be 3x. Integrate 9 over x plus 3. You must understand that this is the same as 9 multiplied by 1 over x plus 3. Can you see that? So the numerator is an exact derivative of the denominator. The derivative of x is 1. So therefore, I can go ln of the denominator. Ln absolute value of the denominator. I'm substituting 2 minus 2. Let's check what we get now. So we got, let's see, let me type this out. There's no trigonometry, it doesn't matter whether your calculator is in degrees or radians. So that's half x squared minus 3x plus 9 ln of x plus 3. Right, so what are we substituting? 2 first. When I substitute 2, I am getting 10, 4, 8, 4, 9, 4, 1, 2, 1. Okay. Minus now. When I substitute negative 2, I'm getting 8. You see that? When I substituted 2, I'm getting this answer. When I substitute minus 2, I'm getting 8. So, this minus 8 is equal to 2, 8, 4, not 8, 4, sorry, that is 4. 8, 4, basically you're just subtracting 10 minus 8, which is 2, and the rest there. 4, 8, 4, 9, 4, 1, 2, 1, which is equal to 2, 4, 8, 5. So you can see it's the same final answer. Same final answer, different technique. Remember, I was always telling you that when we did these two techniques, the answers do not look the same. There's an extra constant when you do this method here. But when you're substituting values, it must be the same. There's a check. 2, 485, 2, 485.